This video is on permutations and combinations. So our objective is that I can calculate permutations and combinations. First of all, though, we have to know how to do factorials. Factorials are written this way, where you have 3 with an exclamation mark, which means 3 factorial. It means that you take 3 times 2 times 1, so 3 times every integer less than it down to 1, and when you multiply that, you get 6. Now, if you do 7 factorial, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you multiply that out, you end up getting 5,040. Okay, so that's the mathematics we need in order to do permutations and combinations. Now, a permutation is where you take a group of items or people and you pick a specific number, and this will tell you how many ways you can line those up in order in a specific way. So if you're, say, lining things up at recess for an elementary school, lining those students up, how many different ways you could line those students up would be one way to put it. Combinations, on the other hand, are when you take a group of items or people and you take those groups, pick out a smaller subset of that, and you don't have any specific order. So how many ways can you do that out of the group? So for instance, if we were doing a permutation, the way we would write out the notation is we'd have NPR, meaning this is the total number in the bigger group, and this is how many we're going to select out of it, and this is going to be the number of ways we can line them up in different ways. So the number of ways you can line them up. So the notation for this, you're going to use factorials for this. NPR is given as n factorial over n minus r factorial. All right, so as an example, if we had a group of, let's say we're going to take a group of 6 students, okay, that are on the playground, and we're gonna do some type of a competition. How many different ways could you have a first and second place out of those students? So notice if one student finishes first, that's one way. If they finish second the next time, that's different, and they can have different people with them. How many different ways can that happen as a permutation? So on this, the way you'll figure it out is you'll do 6 factorial over 6 minus 2 factorial, and that's going to be 6 times 5 times 4 times 3 times 2 times 1. And that's going to be all over 6 minus 2 is 4, so 4 factorial is 4 times 3 times 2 times 1. Notice all of these will reduce out, so you just have 6 times 5, which is equal to 30. So it's 30 different ways you can take those 6 students and get a first and second place out of that group. Let's do a different one. Let's go ahead and do, for instance, we'll do 15 P, and then let's go ahead and do a 6 on this. Okay, we might not calculate this whole one, but we'll get a start on it. So in this one, we'll do 15 factorial on top. On the bottom, you're going to do 15 minus 6 factorial. So it's going to be 15 factorial over 9 factorial when you subtract those two. Now watch, we don't have to write them all the way out. What I'll do is I'll write 15 times 14 times 13 times 12 times 11 times 10 times 9 factorial, because the rest of that will be just 9 and the rest of the numbers down to 1 over 9 factorial. And these cancel, and then we can just multiply those. We can get a pretty big number here. Let's try 15 times 14 times 13 times 12 times 11 times 10, and we get, the number becomes 360, 3600. So that's going to be 3,603,600. Okay, that's how many different ways you could take a group of 15 students and give 6 places, the first 6 places, say in a race or something like that. The number of different ways. That's a lot of different ways. All right, so that's permutations, lining them up in order. Combinations are when you don't put them in order. We often use the phrase "n choose r" when we use this notation. So NCR is the notation. And so what you get is still that n factorial over that same n minus r factorial. So it looks very familiar to this one up here, but you're also going to add in this, you're going to take that r and put another factorial here. So you're going to have more that you reduce out, it'll be a smaller number. So when we do a problem like this, let's say we do, let's just do the same numbers here. Let's do 6 choose 2. You're going to have a 6 factorial. And over this, you're going to have a 6 minus 2, which we'll just say is 4 factorial. And then you list it with the 2 factorial. So the same thing, the 6 minus 2 factorial, but you got to add in that extra r factorial there. And when you write that out, you're going to have 6 factorials is 6 times 5 times 4 factorial over 2 times 1, which is 2 factorial, and then the 4 factorials will cancel. So 30 divided by 2 is going to give you 15. So a smaller number than that original one there for the choose notation. Now let's just do a bigger one. Let's go ahead and do, for instance, 10, and let's choose out of that 3. Okay, so 10 choose 3, you do a 10 factorial on top. On the bottom, you're going to do 10 minus 3, which is a 7 factorial, and then just the 3 factorial by itself. So I'm going to list this out, 10 times 9 times 8 times 7 factorial, all over, and this is going to be 3 times 2 times 1 times, and the 7 factorials are going to reduce out, 7 times 6 times 5 times 4 times 3 times 2 times 1. And so when we multiply these, you can still do a little more reducing, notice, if you want to, but I'll just go ahead and do the multiplication here to calculate what it is. So I got 10 times 9 times 8, and I'm going to divide that by 6, 3 times 2 times 1, and I get 120 as my answer. So permutations and combinations, you have to remember order matters for permutations. Order does not matter for combinations. This tells you how many different ways you can get that group for either lining them up in permutations or just picking a group for the combinations. Use these 2 formulas to get it and do your reducing in order to get your final answer.